The connection between a statement of a problem in terms of functions and the graph of a function is critically important when we study calculus. So in our college algebra class, we want to make very sure that we understand the connection between these two different ways of asking a question. In this problem, I'm telling you on the left-hand side some values of a function that I've written. So I defined a function and I plugged a number of inputs into it, and for each input, I wrote down the output that I got. The connection that we're trying to make here is between an input-output pair and a point that we would plot. Every time we know an input-output pair, we know a point on the graph that we can plot. So if the input 1 leads to an output of 0.2, then I'm going to plot the point 1, comma 0.2 about here. So the input and the output form an ordered pair that gets graphed. Similarly, if the input's -2, the output will be 3.8. We'll put that here, and I'm going to just fill the rest of these in. So the 5 given facts written in function notation lead to 5 points that get graphed on the plot, get plotted on the graph. From the points that I have, it's impossible to really know what the overall function looks like, but we'll see later on that when we have additional clues, like the algebraic form of the function, then we will have an idea of what the shape should be. And once we have a picture in our head of the shape, then filling in the rest from a set of points is not too bad. So in this example, if I were to tell you that the function that I defined was a quadratic function whose graph should be a parabola, then we get a good idea that if it's going to have a parabola shape, then it must go something like this. So similarly, we can work our way backwards. If we have a graph, then by identifying points on the graph, we can write down facts about input-output pairs for the function. So for example, this point on the graph has coordinates 3, 2, and so I know that the function g with input 3 has output 2. This point has coordinates -2, 4, and so I know that putting -2 for input will give me a 4 for the output. And then finally, I have to kind of eyeball this, but I'll say -2.5 input has about a -3.5, not negative. Maybe 3.4 as an output. So input -2.5 leads to output 3.4. So I can go back and forth between facts about inputs and outputs of my function and pairs of points that are on the graph of the function. Try this problem real quick. I'm going to let you think about it, pause the video, and see if you can determine which of the facts on the left are not true for the graph on the right. Some of the ones on the left are true and some of them are false. On the left, I've put check marks next to the statements that were true in a color that matches the dots on the graph that correspond to those facts. The one statement that is not true is the center one, f of 2 equals 4. For that to be true, the point 2, 4 would have to be a point on my graph, and I can see the point 2, 4 is right here. That is nowhere near my graph. So the problems that we have to work with mostly will look like this. The notation looks a little bit weird, but remember, when we have a statement like g of something equals something, that's really giving us an input-output pair. So this fact is the same as saying there's a point on my graph that looks like -1, something. This fact tells me that there's a point on my graph that looks like 3, something. This fact would say there's something on my graph that looks like something, 2. So the translation between the function notation and the points that we're going to graph is exactly the same, but in this case, the problem is more like a puzzle where we're told that there's a point on the curve, but I'm only going to tell you one of the coordinates, and you have to figure out what point I'm talking about, and then the answer is going to be the other coordinate. So for problem A, it says that the first coordinate should be -1, and so there's only one point on my curve that I could be talking about. If the first coordinate is -1, the second coordinate is 4, and so therefore I would write that g of -1 is equal, not negative, good grief. So -1 comma 4 is on my graph, so g of -1 equals 4. Similarly, g of 3 means find the first coordinate is 3, and then see where the graph goes. So if the first coordinate is 3, my graph is here. I'm going to call that about -1.6. So when the first coordinate is 3, the second coordinate is -1.6, and the way I would write that is by saying g of 3 equals -1.6. Part C is a little bit different because we're given an output. I'm told that the second coordinate is going to be 2, and so the second coordinate 2 means it could be several different points. So it could be this point, or this point, or this point. All three of these points have coordinates. They're points on the graph, and their second coordinate is going to be 2. So there's 3 different answers for what can happen in part C. So the number that goes here could be -3 as the input, could be 0, or it could be 4. The input number for each of these points, -3 is the first coordinate of this point, 0 is the first coordinate of this point, and 4 is the first coordinate of this point. So the answer to C would be any of these 3 numbers would make this true. I'll fill in the rest. If you want to fill in D and E, I'll pause the video and then I'll fill those in. And so here you see my answers to D and E. Obviously in E, I'm just estimating. Anytime we're reading values from the graph, we're going to just say some number-ish. So 4.3, 4.4, somewhere in there. Looks like it should be the answer to part E. So finally, this is the way that you'll see problems show up on actual assessments. And I just want you to see that it really is the same thing. When we say evaluate h of -1, that means the input is -1 and we're asking to find the output. So again, we're thinking h of -1 equals what? And that means we're looking for a point on the curve with the first coordinates -1. Same thing for h of 3. We're looking for a point on the curve where the first coordinate is 3. Part C, I'm trying to find any points I can where the second coordinate is 2. Part D, I'm told the first coordinate is 0, and I'm asked to find the second coordinate. And in part E, I'm asked to find the first coordinate, so the second coordinate is 5. So those are the points that I'm looking for. Go ahead and try it. Mark the points on the curve. I'll let the video, pause the video, and then I'll fill in my answers. So here are values that I have for each of the parts. The only one that has multiple answers seems to be letter C. There are 1, 2, 3 points on the curve that have an output have a second coordinate of 2, which would mean that H has an output of 2 for 3 different values of X. And just estimating those values of X, these are the 3 values that I can see here. You'll see I put the word ish after a lot of these when they don't fall right on whole number values. We are just estimating from the graph, but obviously if you put 4.1 or 4.2 or something in that ballpark, that would be perfectly fine. The exact answer is unknowable without having more information or without being able to zoom in on the graph.